Okay, so in problem 2, we have two different inequalities to solve and graph. So let's start with part A. So if you remember the rules of solving inequalities, you can basically do anything you want, anything that you would do with an equation. The only difference is that if you multiply or divide by a negative, you need to change the direction of the inequalities. And if we have a three-part inequality, like in part A, you instead of doing the same thing to both sides of the equation, you do the same thing to all three parts of the inequality. But just like with an equation, what you're going to do is you're going to kind of, okay, say there's my variable, I need to get that by itself. So what's happening to my x? Well, you have your x. First it's being multiplied by 2, and then 1 is being subtracted. So the last thing that's happening to the last thing that's happening to x is that 1 is being subtracted. So we want to undo that by adding 1. So let me just erase this arrow so I can work over here. Okay, so that minus 1 is the last thing that happened in my order of operations, so it's the first thing to get rid of. So if I want to do this plus 1, I have to do it to every single part of the inequality. So I have to do a plus 1 over here and a plus 1 over here. So what I'm left with is 4 is less than or equal to 2x is less than or equal to 10. Okay, see how that worked, right? 3 plus 1 is 4. 2x minus 1 plus 1, right? These go away. So I'm left with just 2x. And then the 9 plus 1 is 10. So now what's happening with that x, right? It's being multiplied by 2. So to get rid of multiplication by 2, we want to divide by 2. Okay, so 4 divided by 2, over here I have 2, less than or equal to x, is less than or equal to 5. Okay, so now let's just graph it. So here's our number line. So here's our 2, 3, 4, and 5. Okay, so I want to put, since this is or equal to, that means that 2 is a solution. So if 2 is a solution, I'm going to put a solid dot there. 5 is not a solution. So anything up to 5 is a solution to my inequality. Remember, a solution to the inequality is a value of x that makes this statement true. So anything that's all the way up to 5 will make this statement true, right? 4.99999, it'll still be a true statement. But 5 itself is not a true statement. So the way that we indicate that is by putting an open circle at 5, okay? And then we connect this line between them. So closed circle at 2, open circle at 5, because that's not, right, we don't have or equals to. We just have strictly less than. Here we do have, or equals to, so this 2 gets to be part of our graph. I guess I'm doing it in red. So basically anything that's shaded is a solution, meaning is a value of x that you can plug in and make it true. And anything that's not shaded, even if you plug it in, you won't get a true statement. Okay, so let's look at okay, so we have over here, we have 7x plus 5, and over here we have 9x minus 5. Now to get a real solution to this, I want to have just x by itself on one side of the equation. So since I have x's on both sides of the equation, I need to move them around in order to get them on the same side. Now you can choose either side. I'm actually going to do this what might be considered the hard way because I want to demonstrate what happens when you divide by a negative. But just keep in mind you can choose to move your x's over to the right side and your constant to the left, or vice versa. Here's what I'm going to do. I'm going to put my x's on my left, and let's start by just putting the x's on the left. So these 9x's are on the wrong side, so let's move those over. So if there were 9x's over there, so let's subtract 9x's from both sides. Okay, so 7x minus 9x is negative 2x plus 5 is less than or equal to negative 5. Notice I did not change the direction of my inequality because I was doing addition and subtraction. Okay, with addition and subtraction, you just leave your inequality sign the way it is. It's only when you're multiplying or dividing by a negative that you want to flip the inequality sign. Okay, so now I'm kind of following the same steps as I did over in part A when you say, okay, I need to get this x by itself. So what's happening to it? It has a plus 5, so let's get rid of that by subtracting 5 from both sides. So here I have negative 2x less than or equal to negative 5 minus 5 is negative 10. So now, when I divide by negative 2, I am dividing by a negative. And when you divide by a negative, you have to flip the inequality sign. So what I get is x is greater than, so actually is greater than or equal to, positive 5, right? Negative 10 over negative 2 is positive 5. Okay, so now to graph it, let me just make some space. All right, here's our number line. Here's 5. Since we have greater than or equal to, I want to have a solid dot, so here's my 5. And x is greater than 5, right? So anything that's bigger than 5 makes the equation true. So when I'm shading in the values of x that actually make the inequality true, I'm sorry, I said equation, I meant inequality. The values of x that make this inequality true are the ones greater than 5, so I'm going to shade everything greater than 5, and I'm going to put a solid dot at 5 to show that 5 is included in my solution.